Okay, we are continuing with writing equations of polynomials, and this next example involves the conjugate root theorem. So go ahead and pause this video and copy this down. It basically says that if you have a plus bi as a root of the polynomial, then you're also going to have the complex conjugate a minus bi. So they're buddies, they stay together. So if a plus bi is a root, then a minus bi is also a root. And we remember that I is the imaginary numbers. So I just equals I. It's a square, and then it's the square root of -1. I squared is equal to -1. I cubed is equal to -I. And I to the fourth is equal to 1. So that's going to be a bit helpful. This example does involve foiling 3 terms, and there is a little shortcut that I'm going to show you, which is going to be really helpful for the next example as well. So let's get rocking and rolling. Okay, if we're writing the equation, so I gave you the 0, so we need to write it as a factor and solve for our leading coefficient, just like before. So we're going to have y equals a, that's our leading coefficient that we don't know. And then remember, when this is a 0, so we need to change the sign on it. It's going to be x minus this whole 0. Okay? And then the conjugate root theorem told us that if 1 plus 2i is a root, then we also know that 1 minus 2i is a root. So there we go. We've got our leading coefficient that we're going to solve for, and we have our 2 factors. And this just gets a little bit hairy because we've got some foiling to do, right? We would well, before we FOIL, let's go ahead and simplify this a little bit. So we would have x minus 1 minus 2i, and then x minus 1 plus 2i. And now we would need to FOIL these 2 terms together. So I would recommend making the box. And what do I mean by that? I mean, you have your first 3 terms, so x, -1, and -2i. And then you have your second terms that you need to multiply, x, -1, and positive 2i. And you can fill in the box there. X times x is x squared, and you can keep going that way. An option that lets you use the shortcut. And the shortcut will always work with conjugates. It's going to be x squared minus the sum of the conjugates with an x, and then plus the product of the conjugates. So for our example, here are our conjugates, right? 1 minus 2i and 1 plus 2i. So for the sum, 1 plus 2i, 1 minus 2i. Well, positive 2i and -2i, that goes to 0. So 2 plus 0, that gives me 2. And then don't forget about the x with it. You've got the x squared in front. Okay, now we need the product of our conjugates. So 1 plus 2i and 1 minus 2i. You can FOIL those. First terms, 1 times 1. Outside terms, inside terms, and your lost terms. So 2 times -2 is -4. I times I is I squared. And we can clean this up. -2i plus positive 2i is 0. And then I squared is equal to -1. So this piece right here is actually -1. So then you have 1, -4 times -1 gives you a positive 4, which gives you 5. So if you continued with the box method, you would end up right here. And we have cleaned up our answer a little bit. We have magically multiplied these using our shortcut. So we now have a times x squared minus 2x plus 5. Okay, and from here it's very straightforward. Just like the other examples. You've been given your coordinate point, so plug it in to find your leading coefficient. This is my x value, this is my y. So my y value is 5. We are trying to solve for a. My x value is -1. And now it's algebra. All this gives me 8 divided by 8. Okay. Perfect. So we now know that a is equal to 5/8. So my final answer is 5/8 x squared minus 2x plus 5. Okay. So I know the shortcut. I know there was kind of a lot going on there, but the shortcut is just going to be x squared minus the sum of your conjugates with an x plus the product. All right.